Hello?
Hello.
Hi.
Hello, everyone.
Hey, how are you?
Hi. I just got up.
Oh, I know, you can see.
Yeah, I'm having some breakfast.
Okay. Well, Ankit, I know that he asked me if we were going to meet today, and we did. I think he didn't realize that we had a time change between, like, probably 2 weeks ago and now, so.
Oh, yeah. Yeah, it's good.
Yeah, it's always a tough time of year. I have to coordinate that switch. It's not the same in Europe, say, as it is here, so it's like...
Yeah, it's not the same in China.
Oh, yeah, yeah.
My daughter's Chinese lesson changed an hour, and we didn't realize.
Hello, Krishna, how are you? All right. I don't know if Jesse will be here.
Hi, I'm good. How are you?
All right, how are you?
Okay, I'm glad that you can hear my voice.
Yeah.
Actually, I've just like transferred to a new city, and the Wi-Fi it's not working very well here right now.
Okay. All right. Well.
Can you hear me?
Yeah. Yeah.
Yep.
Yeah, that's good. So I'm like yet to get a new Wi-Fi. So the current one that I'm using is not very good.
Okay. Yeah. Yeah. All right. So, well, welcome. I don't know if other people come in, and probably Jesse will be here. That's Jenny. Hi, Jenny. And Jesse's here. Hello.
Hi.
Hi.
Nice to meet you.
Nice to meet you too.
Hi.
Did you want to introduce yourself, Jenny?
Sure, yeah, I can do that. Hi, my name is Jenny, and I am a designer and practice-based researcher, and I'm really interested in developing self-reflection technology. And so right now I'm leading an online organization called Plot Twisters, and we're basically developing an online game world that's emotionally literate. We're creating some trauma-informed communication tools and interface designs and prototypes. We're working toward a presentation in December, and I think moving forward, I really want to continue advancing some sort of general framework in this space, understanding what self-reflection and trauma-informed interfaces look like in the future. So yeah, I'm interested in applications for that in emerging technologies from AR and internet-based therapy to different knowledge management tools. Yeah.
Is this in Unity or a game framework that? Game framework?
So we're not actually at that stage yet of engineering. Right now we're developing kind of what the game governance model, what is the basic unit and language of the game. But I think what I'm imagining is not something in Unity because we would want it to work for both mobile and desktop and across different devices. So it might be something more similar to like a point and click game. If you are familiar with Club Penguin or these other like early, 2000s games, something like that.
I have kids.
Oh, good.
Awesome. Well, it's great to be here.
Yeah, great to have you here. Okay. And then hello, Jesse. I see you made it here. So let's get started. We have Slack reviews we usually start off with, and we'll go through the Slack channels, and then we'll move on to some other business. Is there anything anyone wanted to mention before we start? Okay. Let me share my screen.
Yeah, the only thing I would mention is just I don't know if Avery's going to be here. I don't know. Glad to have you here, Jenny. Did you hear from Avery this morning? Or
I haven't seen them.
Okay, they probably won't make it today, but Avery's kind of I forget if Jenny said this, but Avery and Jenny and me were all in the same UK situation, and working on stuff for Neuromatch and just other updates for like people who probably won't be here. Anusha's doing pretty well. She had a second interview for a research job today, this week, and that's something here in Boston. I forget which. I think it's like it wasn't Boston Children's, but it was something related to that. So she's busy with that. Aaron is also in a similar situation. I think she might be moving soon to another city to start a job. And so they're not totally doing anything right now specific to what we're going to talk about today, but they're like adjacent. And I know a lot of the discussion in the ethics channel has been around like Erin would probably be doing a lot in the ethics channel when she gets ready. It's in like the New York computing stuff happening in next year. Yeah. I think we'll be on the cusp of that. I'm glad Krishna's here today. We've heard a lot from Rashab. Do you know if he's going to be around?
I haven't heard from him, but yeah, I saw him in the Slack, so good to see him again.
Yeah, just because a lot of people are maybe not in this meeting, but they're around doing stuff. So that's all my updates for those who aren't.
Okay. All right, let me share my screen here. And so this is the Slack, the Orthogonal Lab Slack. So we have a lot of channels. We usually go through them so that people can focus on things that maybe they didn't see before. So the first thing is not seeing it.
Oh, there it is.
Okay, yeah. All right. Brain Organoids is the first channel, and we have, let's see, we had a lot of stuff this week. We had...
Excuse me, yeah, let me just try and think about, again, the Tarasky talks and the tissue talks are just pretty mind-blowing. I'm new to biomaterials like this, and but I think certainly the amazing result is the science paper that's listed here. So this is the sorry, I've got an iPad and I'm trying not to wake up the rest of the house.
Yeah.
So I can't quite see, but there's a spinal cord repair biomaterial that was I think it was like Steve. Yeah, the last author is Stupp.
Yes.
Yeah. And so I think I dropped an interview with Stupp in Random.
Okay.
For anybody who's interested in getting Stupp's worldview, but again, it's like I've been catching these talks on scaffolds.
Yeah.
Right, because again, it's a big part of organoid work, and then this paper comes out, right, where we're not talking about organoids anymore. We're talking about getting mice to walk again.
Right. Yeah.
And just really remarkable, incredible work, and they are moving to they are requesting testing in humans soon.
Okay.
Like there's absolutely nothing that suggests, again, because this isn't kind of like because this doesn't have anything to do with kind of cellular work,
right?
They're like this should do the same thing in humans.
Yeah.
Right. Yeah, and because again, it's just this remarkable biomaterials work where I have to look up half the words what they mean just because they've got all these very specific, very technical, engineering work that they're doing. So yeah, it's really remarkable.
Yeah, it looks really interesting.
And to some degree, to some degree, not surprising. I mean, I got to imagine that when people understood what the spinal cord was, they at some point they must have thought, well, like, we should be able to repair this,
right?
And as everybody knows, it has resisted repair for a long time, right?
Right.
So really, really exciting, because this could help a lot of people.
Yeah, I think that's like something people have been working on for a long time, and it's really a materials problem, because it's you want to be able to have axons, for example, regenerate across the space where there's maybe an injury, and it's not as simple as just putting some slapping a patch on it and letting it, you have to have the right mix of, you're basically doing like an organoid culture in vivo, and then you're putting it in there and hoping that everything kind of fills in the gap. So that's
and at this point, it wouldn't surprise me if it's all improved by injecting some current in as well.
Sure, yeah, because you're getting.
It keeps on happening where I'm listening to this talk, and then I'm like, and then we found that if we included some current flow,
right,
that it was either faster or better or something. So again, I think Michael Levin wouldn't be surprised.
Yeah. I mean, we kind of use the developmental analogy of like axons with their growth cones, and they're kind of finding neighbors.
Yeah.
And how do they do that? Well, they do that with probably signals of some type, and it's maybe not all chemical. It's probably some electrical signal as well.
If you haven't seen it, I'll try and find it, but I think everybody's seen these. But Slava's been posting a few videos on Twitter of neurons finding each other.
Oh, okay.
I'll find the videos, but there's some great active searching by the neurons.
Right. Yeah, I mean that's something actually we haven't talked about in our developmental AI stuff, is axons and how they find each other and how they organize, like neurons organize their connections. I know we've talked about how we might have neurons that sort of appear in this sequence and form a network, and then we can use that as sort of a an artificial system. But the axon, I think the axon finding is actually a very interesting thing as well.
It's great stuff. But just wanted to Michael Schiller is the tissue talk, and that was a great. I tried in a very brief way, probably not useful to other people yet, but I tried to take some notes of things as they were happening, which is why you'll see these little terms dropped in, at least that I want to follow up on. So just above the a living system on a chip, and it was great to see. It was great, his talk, because he was really giving us history as well as current state of organ on a chip.
Right.
So really, really interesting stuff in terms of, one, he had a great message for grad students who have good ideas. He's like, if you've got a good idea, like, don't let go of it. It might take the funding world like 20 years to catch up.
Right.
but he was saying that, like, these were all ideas he had back in the late 80s. And it wasn't until this Ingber paper from 2011 came out where he said the funding landscape changed with I think it's Donald Ingber, and who's now the head of the Wise Institute.
Okay.
He said that this lab on a chip, or so this is the accompanying Nature paper, not the paper itself. It's the
the
commentary.
Right, commentary.
Yeah. But you can link it. You can see the link to it there. But it's Donald Ingber talking about this, and even though Michael Schuller is not he's not a brain. Most of his work didn't focus on cerebral organoids, but it was also interesting to see what he was doing. He was trying to engineer 2D on purpose, even though you could have gotten 3D. But again, it was all about making the system simpler and getting it more purposefully to make it an experiment, as opposed to necessarily like the closest to being like the living system. And again, like adding electricity for reasons for biomaterials reasons.
Right.
Like, that this would either create porosity, or it would have some other effects. A big part of it was trying to simulate the blood-brain barrier and its functionality, right? So perhaps you were turning on electricity to enable certain compounds to pass that your engineered blood-brain barrier. So again, super relevant, and also links into another talk that I listed there this time in Europe, but that was specifically about blood-brain barrier issues. And the Eventbrite one is I think
this one up here.
The targeted biochemical infusion.
Yeah.
Really important if you are working in humans and you're trying to get something delivered. And for why so many people are interested in blood-brain barrier modeling, or BBB modeling.
Right.
His Schuller's work was also really important for these pharmacokinetic models, and what he was doing in modeling whole body pharmacokinetics. Again, I don't know if that's like of general interest, but really important, or it actually comes up if you're doing brain imaging, near-infrared brain imaging. You're going to end up having a kind of model of the body, certainly of the heart and of the lungs, since those are organs responsible for some of the physiological noise that you're seeing, or some of the physiological oscillations that you're going to capture in the system too.
Right.
And so lots of great talks. What I unfortunately I missed, and we'll have to catch from Bradley Wojtek, is the symposium that they had that was associated with SFN.
Oh, right. I saw that.
And I will have to report next week.
Okay, yeah, that's
But
good. We had a couple of questions in the chat here.
Okay.
So it says, Krishna says, since I'm not having good internet connection, I will type what I did in the past week. He read papers by Cording's lab and Nancy Canwisher, so that was on some good stuff there for Neuromatch.
I saw that paper.
yeah, that was good. And then I've yet to finalize a presentation. Once I'm done with the first draft, I'll share Google slide link. Oh, this is for neural decoding. So I know Ankit was interested in the neural decoding work. It looks like...
And potentially relevant for any something for Maine, for Montreal AI Neuroscience.
Yeah, and we'll talk about that in a little bit. I know people were interested in submitting to that, but well, yeah. So that's good. I had one more thing in the brain organoid Slack, and I just put it in here. This is a review article on human brain organogenesis. So if that's something that you're interested in, this is a review paper. So these are nice, review papers are nice because it gives you a nice overview of the field. And that's always a good place to start on things if you're interested in them.
Yeah. And as you can see from his Twitter there, that this is the head of Stanford's organoids research efforts.
Oh, right, yeah.
Yeah. So I mean, this is there's very lively competition between UCSF, Stanford, and UCSD in this space, which is great.
Yeah.
But there's more work from Northwestern that's less obvious in terms of the paper titles, but they are obviously very active in organoid work too. So I'm just trying to map out the really active research labs.
We should maybe do that. You could even have like a Google map where you have like little markers, places where they're doing this.
So as part of Neurotech X, we've got they've put together a database, right? Because for Neurotech, there's hundreds of sites, right? But it's trying to capture the grad student position availability on grad students, postdocs, as well as research positions in general.
Yeah.
You could have a much simpler one. Yeah, there's not as many, but it would be great. So I've been trying to search on via all the LinkedIn connections as well as on the net, and asking people where they learned what they've done and things like that.
Yeah. Let me go back to the screen share here. I like to refresh every once in a while. So now we're in calls for involvement. This is for the Turing-Way project. So this is an open source project that involves a lot of sort of open science collaboration. Did you want to mention?
And the book, the book is kind of a compendium of best practices for data science and open science, and that was definitely a big part of. I mean, so the Turing Way is I think what they call the book, but it's I think somebody posted before like Git book as a
right
collaborative kind of layer on top of Git.
Yeah, I think that was Ankit. Yeah.
Yeah. Anyway, please check out the Turing Way, and Kirsty has regular talks. Regular updates for people and opportunities to talk to her. As do some of the other principals. It's a really great group, and for those not familiar, This is a central data science institute for the UK across now almost 10 universities. It was originally 5, but you know, so it's like it's an incredible group of researchers that are get to share across the universities.
Yeah. So that's good. Then speaking of data science, there's Data Science ML, which is another channel, and we had a couple things, the one thing this week, and this was the physics-based deep learning. This is physics-informed learning machines for multi-physics and multi-scale problems.
Yeah. So I also had an interview, and so I put this together in terms of what I was supposed to state, you know, what I thought was really interesting, that was kind of new technology. And it was nice to do this before any of NVIDIA's keynotes.
Yeah.
Because you know, this is something, certainly the work from Crunch at Brown, and forgive me for not being able to pronounce the guy's name. It's a great Greek name, but he has just won the Siam Prize, I think, for 21.
Okay.
And you know, these physics-informed neural networks. In his case, it's this DeepONet, which is I believe Brown has patented it. So I can drop in. He I think after NVIDIA's keynotes, they dropped an archive paper comparing DeepONet to a Fourier neural ODE that I should probably drop in. And anyway, the Pacific Northwest National Labs has the multi-scale, multi-physics or physics-informed learning machines is really super interesting for those doing electromagnetic modeling, for instance, and other kinds of things. So these are all, you know, I think really exciting, you know, kind of research programs on top of deep neural nets, right?
Yeah.
And they're you know, so I'll let the PNNL site, you know, be great, you know, great reading material for what this is adding on top of, you know, just deep learning.
Yeah, that's good. And it looks like Ankit put a link to the Turing-Way materials in the Data Science ML channel. So if you want to...
And for those didn't catch any of the keynotes, you know, NVIDIA dropped a bunch of new libraries that are also, you know, they are super exciting and allowed, you know, because they're all, you know, CUDA. This is allowing you to do certain things, you know, in a highly accelerated fashion. That's and even moving into quantum computing.
Right. Yeah, that's great. Yeah, people have been doing some really interesting things with neural nets, especially like with graph learning and with other things. I don't know if I posted something. I think it might have been in the DevaWorm channel in another Slack, but it was on cellular automata and using deep learning to sort of do those kind of simulations.
It was when I saw about, you know, 5 years ago, when I saw that these massive astronomy simulations were turning to neural nets for optimization, and that they were, you know, like 3 orders of magnitude faster, right?
Yeah.
That it was just like, okay, well, we're obviously all going to be doing that then, right?
Yeah.
Sorry. And it's I mean, you're seeing that more and more in astrophysics, right?
Yeah.
And it kind of relates to some of Jeff Klune's work and others of kind of the gecko world, where it's like they're using evolutionary computing to do much more efficient optimization. So again, like it was just a better way to search really high dimensional spaces, right? Without brute force approaches. So it's like, yeah, learn it now, because we'll all be doing it in 10 years or something.
Yeah, definitely. I was really into a lot of the stuff NVIDIA was doing with GPUs and that about 10 years ago, and then I kind of lost track of what was going on. But yeah, they've always got some good stuff going on there.
I mean, it's a specialized kind of programming,
Right.
And so it's a little inaccessible unless you're also working with someone who can add functions that are make those available to you in your scripting language.
Right.
In my case, is my scripting language.
Right.
Yeah, but this is the goal of something like Julia, right? Is that like we can hopefully not write specific GPU code and get that acceleration. Yeah.
So, and then speaking of this thing I just mentioned about graph cellular automata. So this is the article here in Dev AI. So I just put it in there. I also put an article on. Let's see if this is from the 9th. So actually, Ankit put an article here on an E. coli biocomputer solves a maze by sharing the work. So this is where they're modeling a biocomputer. So I guess, a genetically engineered bacteria rigged up as a distributed computing system might help realize synthetic biology's loftier goals. And this is where they have an E. coli. I don't know if it's inspired or if it's like a bacteria that, like, I don't exactly know how they're doing this, but they basically get it to solve mazes in a distributed fashion, and then they are able to do so. I don't know if
sounds like slime molds.
Yeah, well, yeah, but this is E. coli, so it's
sure. No,
yeah,
that's cool.
Okay.
I wonder what they've engineered, or what they were modifying.
I can't seem to access the article, but yeah.
Maybe some sort of cell signaling.
Maybe, yeah. Did you have anything to say about this article, or let's see if there's anything in the chat? Yeah. Okay, this is something that Ankit put in the chat on.
Sickle. I think was Sickle's Intel's. I think it was an Intel framework for distributed processing. Yeah.
Okay. Yeah. We should.
But I'm not sure about Hipsicle. Yeah.
Oh yeah, I know. We should talk at some point about like distributed or parallel computing. I think there are a lot of interesting topics there that range from like biologically inspired stuff to different things where you have specialized programming languages to maybe what you can do with it for things like games and other things.
So just for those interested in this supercomputing, the conference is coming up next week, and so that also is that tells you something about NVIDIA's timing, right? This is the largest supercomputing conference or high performance conference. It's like where everybody shows off.
Yeah.
And so Intel, has been trying to make inroads. You saw the thing somebody posted a couple weeks ago in terms of I think it was Microsoft trying to get again like accelerated GPU code that works on not just NVIDIA chips.
Right.
But from something like Oak Ridge National Labs, right, which gave us LAPAC, BLAS, LAPAC, and kind of engineered Fortran code. You know, there's like efforts that are kind of like SYCL that called Magma that works across, you know, multi-core CPUs as well as GPUs.
Yeah.
And you'll see all of these. It's SC21.
Okay. Yeah. If you could advertise that in the Slack somewhere.
Sure.
And then I had this article on the multiple problem solving brain. So this is an interesting article. I can't seem to access this one either, but this is, and I know that maybe Jesse knows who this person is, Julian Miller. We did the Devo NN workshop in 2020 in the summer, and he was one of the organizers of it. So this is a person who is doing this sort of developmental neural networks type work. So this is a new paper in Artificial Life Journal. INPROBED is the acronym. It's multiple problem-solving brain via evolved developmental programs. So this is artificial neural networks were originally inspired by the brain. Very few models use evolution and development, both of which are fundamental to the construction of the brain. They describe a simple neural model called INPROBED, in which two neural programs construct an artificial brain that can simultaneously solve computational problems. One program represents the neuron soma, and the other the dendrite. So that's an interesting approach. The soma program decides whether neurons move, change, die, or replicate. So it's basically controlling the cell itself. And then, the dynamics of it. So it's like a small program that says, this cell will die, this cell will live, this cell will replicate. And then the dendrite program decides whether dendrites extend, change, die, or replicate. So this is like what we were talking about with axon pathfinding, where except they model the dendrite, and the dendrite does similar things when they're trying to establish connections with other cells. And so since developmental programs build networks that change over time, it is necessary to define new problem classes that are suitable to evaluate such approaches. We show that the pair of evolved programs can build a single network from which multiple conventional artificial neural networks can be extracted. So they're using these two types of programs for two different things in what we would map to the biological system. Some dendrite system and a cell, and then we're trying to match those up. We're evolving those independently, as it were, because they're using I imagine they're using some sort of genetic program or some sort of selection function here with respect to some of these programs, because you're getting programs that replicate or die based on some criterion. And then we show that so they can build this single network from these programs, and each program is solving a different computational problem. So what they'll do is they'll build this, this model of a cell or this neuronal system, and they'll build sort of parallel, have parallel sort of goals, and then they'll integrate it into a single network, and then that network can solve problems. So this is a very interesting. This is something they call Cartesian genetic programming, which is an approach that their group does. This is something I haven't been able to get access to this article, but if someone can, please share it. And then finally, this article on graph cellular automata. This is an archive paper. So this is a thing that they're doing with. So they're using graph neural networks, and they're using those to. They're putting those onto a sort of a surface or a topology, which is what you do with cellular automata. It's a bunch of cells or a bunch of particles that are sort of in a field, and you evolve those according to some rules. And so what they're using graph neural networks to derive those rules, and they can create a lot of interesting patterns with this, a lot of emergent patterns, and sometimes they say oscillating bunnies. And if you know anything about the game of life, which is a type of cellular automata, you can generate all sorts of things that look like they're living and pulsating, and so there's this property of the neural networks that they're able to capture. And so they're going to be at NeurIPS with this paper. So that's something else too in this channel. The next channel is Ethics, Society, and Tech. So this is And this is something, I know Krishna was here earlier, and okay, so let me start off up here a little bit. So we're, I think this was from last week. This is from this week. So, okay. So Angela gave her talk a couple weeks ago and on data trusts. And Krishna was asking questions during the talk, and he's really interested. And I think Angela brought up the prospect of funding for this. And so it looks like there's a pilot project ongoing in the UK on data trusts. And so this is something that Krishna and Angela and probably myself would be involved with, maybe Jesse, Ankit, and Jesse reacted with eyes. So that means that they're maybe interested. I think this is something, I know Angela is not here, but if we go through this data trust pilot project, if you go, and I think if you go further up in the channel, there's a link to her talk on data trusts. So it gives you an idea of what data trusts look like. So basically, they're looking for applications from individuals or organizations who want to set up a data trust to serve the community. So this would facilitate independent stewardship of data through the actions of data trustees, support individuals and groups, and people who are collectively negotiating the terms of data use and providing strong institutional safeguards. So I'm not really sure, I guess maybe what they want to do here is set up a data trust. I don't know. It looks like the information session has already happened. I don't know if that's something that would be sort of a... Okay, I don't know. I think this timing is passed on this, actually. You have to submit a letter of intent by September 30th, so we missed that, and then their shortlisted projects. But I'm sure there's another round of this. So this is something that maybe we can look into, where other opportunities like this. I think it's a good idea just to see what people want to fund, what people are interested in this area. I don't know if they have like a list of, well, I guess once this project is, the winners are announced, maybe that's another good time to look and see what they're funding. Like, what groups are they funding? How are they planning on applying these things? Because the one thing I noticed in the talk was that we didn't really have any good examples of data trusts. It was just kind of like, here's a data trust, here's what it is, and which is good, but it's, we need to have a little bit, I think, better understanding how these things are applied. And then, if we want to do it as an organization, you'd have to set up, like, get an initiative going and, have a good, clear idea of how exactly it would be set up, what would be the scope of the types of things that we're looking for. So, we can talk more about that later. I don't have any, I think it's interesting, but, we need to do a bit more work on this. We also could do, like, I don't know if Jesse was able to talk to Angela about presenting at New York Celebration of Women in Computing, but that's something maybe as a next step for this as well. Something where she can, like, hone down some of the materials from the first talk to something maybe more, how would you apply this? I mean, I don't know.
Yeah, I haven't directly, we haven't really had a chance to specifically talk about the next upcoming conference, but I think what you're saying is basically the case. And I think in general, either that being a specific, I think I said this last week, but either basically, depending on what else the lab wants to do in this vein, I think there's a pretty significant interest in the lab of getting behind the project in general. So it could be like the lab goes and presents that specifically as like a whole. It could either be sort of its own project, because I know Angeles has a lot to say about it, or it could be part of a buffet of topics that we put into one. Because the way that the conference works is, I think last year we did a full like research presentation talk, and that was like 20 to 30 minutes or so. So I mean, like that, I think Angela could probably spearhead a large chunk of that, but we could also, like, I think it. We have time. We have a couple of months to sort that out, and I haven't really heard back. I'll probably be volunteering with them in some capacity, if not being more of an organizer. I haven't really. It's kind of a holiday. This isn't really a great week for communicating about that conference.
Yeah.
Because I'm very close to some of the organizers, but yeah, I think it could be. There could be a lot going on there, and it'll just be kind of seeing what Angela wants to do with it. I don't know if there's anything. I know the conference itself is in April again, so
Right.
I guess we'll see what's any other intermediate steps before then. But yeah.
Yeah. All right, that's good. Well, let's keep on top of that. That sounds like it could be it could have a good outcome. So that's our ethics channel for today. Yeah, please join in if you're interested. The next one is game theory, which I noticed had some things in it. And so game theory again is, let's see, there's one thing in there. There's mastering Atari games with limited data. So this is a paper. So this is, I don't know, this is Lab MLAI. This is I don't know if it's reinforcement learning or straightforward AI. This is, this is reinforcement learning. So this is reinforcement learning has achieved great success in many applications. And of course, in reinforcement learning, one of the big benchmarks are these Atari games. And so if you're younger, you don't necessarily remember the first round of Atari games when they came out on the 2600 or whatever, but they were these games that were somewhat...
I'm that old.
Okay, yeah. But yeah, so by today's standards, they were somewhat poorly programmed, but that's the best they could do back then. But they're very simple games in terms of complexity. So if you go to like a game where they, have like asteroids or something where they're shooting, you have a very simple objective, and the graphics are very simple, but it's a very good game for reinforcement learning as a reinforcement learning benchmark because it allows the program to really kind of operate in a somewhat constrained space. I mean, if you just throw a game into, say, like a massively multi-online player game, it would be, it would really be hard to like benchmark because it would take so long for the algorithm to sort of find, maximize its behavior and things like that. But so sample efficiency remains a key challenge in some of this work in reinforcement learning, with prominent methods requiring millions or even billions of environmental steps to train. So a lot of these, reinforcement learning, when you teach reinforcement learning algorithms, a game like Go, this is something that's a pretty straightforward game in terms of the, there's a lot of complexity in terms of steps forward, but the rules are fairly simple. The environment doesn't change a lot. It's just like you have basically this decision tree that needs to be mastered. So, but this is the thing that they're trying to get at with this paper. Recently, there's been a significant progress in sample-efficient image-based RL algorithms. So these are sample-efficient, meaning that they take the most information they can out of each sample that they get. So they get a fairly low amount of information from the environment, and they're able to act upon that. Consistent human-level performance on the Atari game benchmark remains an elusive goal. So they've been able to do work, they've used these Atari benchmarks quite successfully, but sometimes getting human-level, performance is a bit tough depending on the game. So they're able to do this sample-efficient model-based algorithm built on mu0, which we name efficient 0. Our method achieves 190.4% mean human performance, and 116% median performance on the Atari 100K benchmark, with only 2 hours of real game time experience. It outperforms other algorithms for that benchmark. This is the first time an algorithm achieves superhuman performance on Atari games with such little data. So they've been able to do achieve a very high level of performance with limited amount of data, which is like 2 hours of training time, which is, pretty good. If, and you can map that to like some real world problem where, it would take a lot longer to train the algorithm, but it would do, a good job of like getting the basic contours of an environment, say, right. So Did we have anything to say about that? I know some people are interested in reinforcement learning. We have a couple things in the chat. Oh yeah, Ankit said this is wonderful. And then Jesse has a link to retro games for those who want to educate themselves about Atari and other older games. So yeah, that's.
Yeah, I was educating myself about those games this week as a break from my application process. So I kind of found some things there.
ColecoVision.
Yeah.
I mean, I could go on, and I think.
Yeah. But yeah, that's a fun area. Actually, there was a lot of, back then, I guess there were a lot of programming tricks that they use that are quite novel. And if you read the stories, there's stories online about this where they would have like a very small amount of memory, and they'd have to build these games in that space, in that buffer. So they'd have to like do all sorts of weird programming tricks.
This is what Carmack is famous for.
Okay, yeah. John Carmack does a lot of VR stuff now.
I mean, that's how he got his reputation. Was the tricks he'd pull off that, you know, once understood, you'd see the kind of the math behind them, but he seemed to just intuitively find these solutions.
Yeah. Okay. Then there's the general channel, which is, let's see what's in there. I think I announced this meeting in there, and then we had this paper by Ankit. Unsupervised deep learning identifies semantic disentanglement in single and ferrotemporal pace batch neurons. So this is something that is a deep learning paper, but it's looking at something in the brain and how. And I think this is Botvinnik, who I think does a lot of work with neural networks as well.
Well, Demi is a middle author. Is Demi?
Oh yeah. Demis Hassabis is another deep learning researcher, I believe.
But he's the CEO of DeepMind.
Oh, DeepMind. Okay. Yeah.
So this is Irina Higgins. Okay, and so her ICLR history is from 2016, I think, is this kind of disentanglement, or has been variations on a theme of disentanglement.
Okay.
Which is awesome. Yeah. Then these beta variational autoencoders is what she introduced in 2016, 2017.
All right. Yeah.
So really interesting. Yeah.
Yeah, I'm not familiar with that area. Well, I know what VAEs are, but I didn't know that who developed them.
I mean, the only reason that we dug into this was that she was the DeepMind researcher associated with X, the moonshot company, their effort on EEG and depression.
Okay.
So it was trying to understand Irina's papers on beta variational autoencoders plus this this other technique they called SCAN. Excuse me. That was again trying to make interpretable ML results. But this would be, this is even better. Because I guess this is macaque IT cortex.
Yeah.
So super well studied. A lot of people are going to know lots of results from here, and it'd be they must be reporting something pretty impressive. And
it looks like almost like sparse coding is what they're trying to. Which is where they you have a bunch of neurons that. Maybe a few neurons that encode a lot of information that you can, that the organism or the animal, in this case the macaque, would use to identify faces or something like that. And they're using this machine learning model. And this looks like they have a number of different sort of this active appearance model, which is a model for face perception.
I mean, and that comes up in that comes up in other areas.
Yeah.
It'd be a really interesting paper to read.
Yeah, I know we were doing some work on, or I was advising some students on some work over the summer at Neuromatch where, they were doing like trying to correlate brain networks extracted from fMRI data and deep learning networks and looking at the different layers and seeing what the layers were generating and how there's a method that they use to sort of look at the correlations between, like, say, in this case, I think it was layers of the visual system and layers of the deep learning network. So you can actually, there are some interesting correlations there, but it's still an area I think that's, there's a lot of potential there. So, and then this call, actually, this is something Rashad pulled up on the Doug Engelbart. Let's see, where is that thing? That's not it. So this is the thing about the pilot projects for data trusts. There was an article on Doug Engelbart, something, let me just reopen it. This was something that it's on augmenting human intellect, a conceptual framework. So we talked about human augmentation and some of the things that W.R. Ashby wrote on this, and he did this stuff about design for a brain and looking at augmentation of the brain through cybernetics. This is Douglas Engelbart, who was an early, human interface researcher. He developed different tools in that domain, and he has a lot to say here about augmenting human intellect. So he comes up with this conceptual framework, and so this is typical '60s language. By augmenting human intellect, we mean increasing the capability of a man, a human, to approach a complex problem situation, to gain comprehension, to suit particular needs, and to drive solutions to problems. There isn't a lot of fitting this to a problem domain, but it's this is just kind of a vision paper. So there was a lot of kind of this fuzzy language, and then talking about very specific applications. We include the professional problems of diplomats, executives, social scientists, life scientists, designers, whether the problem situation exists for 20 minutes or 20 years. And so this is just the idea that you can have these, whatever they're doing in terms of their work, that they can, gain insight from computers and, augment their intelligence. There's no real definition as to what that architecture looks like, but it's just kind of a vision. And so this is very consistent with what Ashby talked about in his Design for a Brain. I think this is a lot of the early human-computer interaction stuff was really in this vein. This is what they were kind of trying to do with a lot of this technology. Is they were trying to improve. It was really a business. It was really, I think, oriented towards business a lot. And you notice that up in some of this diplomats, executives, and then attorneys. They were trying to increase business productivity, and that was one of the main goals of a lot of the early research. But also, we have these computer-aided working systems. We don't really know what they are at this point in history, but they're kind of going through this work. So they're kind of laying it out in terms of artifacts, language, methodology, and training. So artifacts being the physical objects, language being the sort of the way you parcel the world or picture the world. Methodology is a goal-centered problem-solving activity, and training is a conditioning needed by the human to bring their skills into these different domains. And so this is the way they envision this sort of system. And we know it now today. We might use a mouse to click on things, and we have a human language. We have a visual language. We have computer language, which is underneath. At the time, you might have to do some code yourself to get these things to run, but it's, so we've kind of worked out a lot of these things in our current technologies. If you go to Windows 11, for example, a lot of this stuff is sort of seamless under the hood, but this is what, this is the history of what they're drawing from in designing for this stuff. And so, this is, an interesting article. They talk about intelligence amplification, which is something that Ashby also talks about. And again, like intelligence amplification is one of these things that, how do you amplify intelligence? We think about amplifying a radio signal or some other type of, signal like in a speaker system. We have like an electrical, they use this analogy sort of electrical regulation where you're increasing the gain and all this. But, this is, of course, a human system, so it's much different. But they're using this sort of language of, like an electrical engineering system. So he actually says, this term is originally attributed to W. Ross Ashby. At first, this term was rejected on the grounds that, in our view, one's only hope was to make a better match between human intelligence and the problems to be tackled, rather than in making man more intelligent. But deriving the concepts brought out of the preceding section has shown that indeed this term does seem applicable to our objective. So this is basically the idea of just augmenting human intellect. And then what does that mean? How do we measure that? How do we, we use like interfaces like this. I guess they amplify our intelligence by allowing us to sort of organize things outside of our brains. And this is something, people talk about now in terms of externalizing intelligence. So I think there's a lot of interesting stuff that people could revisit on this.
And IARPA IARPA has competitions on amplifying human intelligence.
Competitions.
So you can,
Who's doing this?
2017. I've still got the data set because I think it's a really interesting. It's an interesting snapshot of what they're trying to do. But this was it's actually based in Urbana-Champaign.
Okay.
So they were doing, electrical brain stimulation, but on a visual motor task. And so the question was, there was a number of questions that you could potentially kind of succeed on. So one was like, could you predict who would respond best to the manipulations? So it was like, trying to give. This is what cognitive neuroscience people do, right? Try and give people a task that captures, some aspect of what you're trying to study. So in this case, can you make people better at this task, right? Through some manipulation, whether that's external or whether that's some sort of, training you give them and they're internalizing it somehow, So yeah, this is IARPA together with IEEE Brain and Charles River Associates was doing the judging.
Okay.
Yeah. Good stuff.
Yeah.
And yeah, I do want to see if we can make the data set publicly available. They had they only gave us a small subset, but I think they had like almost 600 subjects.
Okay. So Jesse, would that be something that would be useful if you think, like, I know that you are interested in doing some of this sort of work. I don't know about this specifically, but would that be useful, do you think?
Which thing? The
Well,
data set, or
yeah, the data set, but in more generally following up on this sort of thing.
Yeah, I forward the link to the Cognition Futures channel, and that definitely fits with, it hasn't been my most active project, but just for those who are new or don't know, but like, one of the projects within the Cognition Futures research group was sort of just having models of cognition or how people envision these different frameworks, and it fits with that. And you're creating a catalog for that, and even there's like there are some things that we haven't really been able to talk about, but some things that Jenny is doing with plot twisters and some of the mapping I've kind of talked to her a little bit about mapping and some of the frontier mapping of different, I don't know, elements of cognition, let's say, and how they would how they fit with that. And there's kind of an overlap between like that paper and a lot of the old cybernetic stuff and you know, maybe modern day applications in VR spaces. That there's a bit of a nexus around those things, and I think in the, you know, I'm still kind of in a stasis for what I've been doing this month, and I'm kind of glad that the end of the year is approaching. But in the future, I see a lot of those threads interweaving into some interesting projects. So yeah.
Just related to that, I mean, so I was telling someone that that I was going to apply to the Middlebury Summer Language Program.
Okay.
Right? So for those not familiar, this is a program where you take a language pledge, you know, that you're only going to speak the language that you're studying for the 7 to 9 weeks, you know. And I think, I mean, this is an annual thing, right? So it's been going on for, you know, 34 years. I've done it before. I've done it 2 summers before. I think it's a really incredible cohort to study.
Yeah,
you know,
yeah.
Like we should definitely get data from these subjects like before, during, and after, because every summer they're coming through for, you know, at this point I think they're learning like 12 different languages. You know, there's 12 different groups, so you can have big groups or small groups, and you know, the brain changes that you know are most certainly going on, right? Are remarkable and widespread, and you know, these are people who in this short brief time, right, 7 weeks, are going to potentially stop thinking in their original language and start thinking in a new language, right?
Yeah.
And that certainly happened to me the first summer, and also, yeah, like if you've got ideas about, you know, accelerating learning, or you know, improving any part of this process, you know, then this would be, again, like an incredible cohort to work with. So I've never approached any of the professors or administration with these ideas, but yeah, if somebody's got good ideas, I think this is a really special group to work with, you know. And I don't, you know, whether it's, you know, injecting electricity into their brains or doing something, yeah, would be, I think, pretty exciting.
Yeah, it'd be great. So let me finish up the Slack review here. We have the main conference, which is coming up. The abstract deadline is the 21st, so that's about a week away. And I know people were interested in submitting to Maine. Maine is like a machine learning, deep learning conference. They call it NeuroAI, which is, you know, and Rashab says Maine is one of his favorite conferences. So the answer about submitting something is yes, you can submit anything you want as an individual. They have submissions where you can submit an abstract, or you know, an abstract and a graphical abstract as well, like a written one and then a graphical abstract, or also those 2 things in a video. So there are a lot of options to submit, and it can be on any topic. So they're very short submissions, and I've been working on one. Like, I'm going to submit for our group on our stuff on developmental embodied neurosimulation. So this is a theme that we've been working on for about 2 years, or a little bit more maybe now. This is developmental embodied neurosimulation. This is a 1,500 character abstracts. This is what they're looking for. If you want to submit something on your own work, or an idea you have, you can do that through your registration form. But it, you know, has to be about this size. And kind of, this is a very general thing that, you know, kind of going over the idea that we have for this type of approach. This is sort of like what I presented at EI workshop on behalf of the lab. So, but it's a little bit more developed. We have the Gibsonian information preprint out now. We have some other things that are, you know, a little bit better developed. And then we have the graphical abstract. And so this is how you do a graphical abstract. Or at least this is how I'm doing it for this. I laid this out from some of our talks and other work that, so this kind of goes over some of the papers that have been put out on this, like the MetaBrains paper, the DevoNN workshop paper, the Continual Embodied Learning paper, Developmental Brain Vehicles paper, Gibsonian Information preprint. And then this doesn't have a paper, but this is part of the written abstract. And so you want to map what's in the written abstract roughly to this thing. And you want to put graphics on it. So you want to put like figures or things that like capture the eye. That's the whole point of a graphical abstract. And so this is all the authors on here. We have 10 authors, and these are the authors of all the papers that are listed here. So that's good. And so this just gives people an introduction. And then the last part of this, I'm going to do a 2-minute video and kind of walk through this graphical abstract for people. And so then that'll be submitted, and then, that'll be, I think, part of the conference. It'll be pre-recorded, but people will be able to get an idea in the neuro AI community of what we're doing.
Yeah, that's cool. I was wondering what you were gonna do in that, and I thought it might be in that vein. So, if there's anything that you need, help with on that, let me know. But it looks like it's kind of we've had this for a while, so
yeah,
it's kind of ready to go. So.
Yeah, I think in the way we're approaching this, and this is like a point on project management, is like, when you have something like a big vision like this, this is a way to modularize your ideas. So you say, well, we need these parts here to make this happen. We want to do this thing on information theory, maybe VR, and I'm just kind of coming up with ideas. Maybe brain mapping. And so you'd have like all these little preprints or papers that you would produce on this, on different topics. And then you'd have this thing, set of topics that you could like say, okay, this is our approach. And you just kind of walk through, and you have all these different pieces. And then, from there you can say, well, let's do some work on it. You can do work concurrently, but it gives an outline of a vision. And then you can say, this is good maybe even for like a dissertation where you have like different aims that you want to accomplish, and say, I have this main idea for your dissertation. I want to do like have a component on information theory, a component on VR. You would develop those parts sort of in modules and then organize those into chapters, and then you'd have like some empirical work, and it would all kind of flow. And I think that's a good way to approach some of these bigger minded projects. You have like these ideas that are, if you just kind of approach it like in an outline, say I'm going to write a paper on it, one paper, it's going to be 150 pages and probably not very compelling. But if you have like, if you work out the parts modularly, and then you do maybe some empirical work, eventually it gets this really compelling body of work. And so just that's my word on that.
Yeah.
So yeah, there are a couple other things that we're neuroscience networks. We're running short on time here. Then this, we have a paper here. This is a nice one. This is Krishna and Ankit and Jesse will probably be interested in this. This is a bibliography and work on deep neural networks versus brain and behavior. So this is like a lot of works, and we talked about a paper just a couple minutes ago on their modeling macaque face recognition. This is inferotemporal temporal neurons here more generally in monkeys, and you have these like statistical properties that they're trying to approximate, or there's a comparative biology approach to deep neural network modeling of vision, which I think is really interesting. Focus on differences, not similarities. So, there are these models that we have, the neural network models. We want to map them to what's going on in the brain. And so what people will do is they'll take these model regions or networks, and they'll look at the statistical properties of these things, in terms of neural coding or connectivity, and they'll look at like the neural networks to see how they compare. And so this is a nice bibliography of a lot of this work, because I wasn't aware that people were doing like some of the stuff like I see in here. there's like, there's ecologically motivated image data sets, things. So these have connections to feedback, connections to ecological psychology, connections to other types of even brain imaging. So it's, and then there are like these general reviews, like building machines that learn and think like people. This is a Josh Tenenbaum et al. Thing in Behavior and Brain Sciences in 2017. So this is something like, I've told you about Behavior and Brain Sciences papers before. They have the paper and then they have all these comments underneath. And so the responses are often maybe more enlightening than the paper sometimes. So this is a pretty long bibliography. So this is probably useful to a number of people in the group. Then finally, I think I'm going to go to virtual reality, and this is in Neurotech, this channel. This is, okay, Jenny joined, very good. This is, let's see, this was from last Saturday. There's a Neurotech X Hack Night recording here, Crowdcast.
And another one that that I'll post from yesterday, or from Thursday night.
Okay, yeah, this is the,
Yeah,
so it's nice to get these recordings because I think a lot of us miss the meetings during the day or they're at inconvenient times. So
yeah, and it's really nice. The Crowdcast, our Jitsi loses the chat.
Oh yeah.
So we do a 3-hour session and we're just constantly dropping links in the chat. So that's what's really great about the Crowdcast.
Yeah, that'd be great. So then there's this Facebook technology. So I know we've been bashing Facebook, but also they do a lot of good stuff in VR. They
have a lot of perceptual vision scientists.
Yeah, I noticed that. So they're doing this. They're doing a lot of wearable computing, as you see here.
And yeah. And I said that they hired a lot of really great people when they bought Control Labs.
Yeah, they've bought a lot of, they've spent a lot of money on developing a lot of stuff for virtual worlds, and so like the metaverse stuff is not just like a vision. They've been doing stuff with it, but this is actually also some good wearable computing. And wearable computing is of course where you put something on your body and you have this digital device, and this goes back quite a ways in terms of probably back to Engelbart in terms of what this could be, the vision for it. But this is actually, where people are developing artifacts now, and they have these, devices. And I think the missing part here, and this may emerge out of some of these, what you've had is a lot of proof of concept things. So you get wearable watches and you test them and you say, this is cool, or this is maybe makes your life easier, easier to do certain things. But there's not a lot of theory, or not a lot of there's a lot of vision, but not a lot of more rigorous theory in terms of what is going on. And I know people have approached this from an embodiment standpoint, but it's really kind of maybe behind the technology a little bit. So, if you're talking about embodiment or enactivism, what is it in those areas that, how can you map it to specific technologies, and how those things work, and maybe even putting metrics on them, how would you measure a certain amount of immersion or embodiment that some of these things would provide. I mean, there's a lot. I think there's a lot of opportunity in this area. So this is a nice kind of view of what people are doing in this space. So yeah, and if you find interesting things in VR, please put them in the channel. There's just a lot going on. And then there's Cognition Futures, of course. We got the link to Engelbart's article, and then this Morgan put a couple more articles in data science, AI.
I just put just a couple more about the physics deep learning. That's really relevant.
Okay.
One thing I would ask you all, as a friend of mine was asking about, basically a master's program, particularly in the European Union, that was VR based. Do you know anything like that? That's like a graduate level program that's focused on virtual reality stuff in the UK, or not in Europe, or here in the US, but like they're Eurocentric.
So I mean, please, this would be great if they wouldn't mind testing out NeurotechX's new database, because you should be able to put in like virtual reality and get graduate programs. Whether it can be specific for masters or not, just the ones that are coming, certainly in the States. I'm just thinking about the USC program, but I'm sure there are others. Is there, our house is probably another place where I'd check, just because they are very forward thinking. And they have a interacting minds. I know they have this interacting minds program. So it's VR plus, it's like, yeah.
Okay.
They're interested in, I know, doing like hyperscanning and things like that, which maybe is not this person's interest, but there's two minds. Yeah.
Okay, thanks.
Yeah, it's very good. So I want to go to a couple things here. I wanted to talk about Neuromatch, and I know we were talking about how do we fit all this stuff, these talks that we're doing, into 5 minutes. And I know, like, especially for the group, like Jenny and Jesse and Avery and myself, we're on that sort of the philosophically oriented work. How do you fit that into 5 minutes? So I've actually fit in, I think this is it here. Yeah, no, it's graphical abstract, this one. So this is the, I recently received this title slide from Neuromatch. They want us to use this title slide, just so you know what that is. And then this is the talk, the switching talk that I submitted with Ankit as a co-author. And I don't know if anyone else wants to be on it, but we can do, like, if you want to edit this document. But I think we've got it down to 5 minutes. Let me show you what a 5-minute talk would look like. So you'd want to have this cover slide here with the title and the authors. And then you want to go into sort of the key ideas here. So in this case, a philosophically oriented paper would be a little bit different. It would be like maybe introducing terms up front. You want to use some images, because it's, in 5 minutes you want to be able to go through and really kind of get people, they say a picture is worth 1,000 words. And if you have a picture and you can see something, it's you get it a lot more quickly than if you have to read through a lot of text. So, visuals are key, even diagrams, things like that. Even if, it's like a word cloud, or like a bunch of words kind of, with some definitions spaced out, it's a little bit better than having a wall of text. So, we have these two slides here where we talk about some of the higher order concepts, cybernetics and bistability, and then go into these examples. This is a bacterial nanomotor. This is algorithmic switching, which is, of course, Ankit's paper on the Fliskopt program. And then some attentional switching, which is, again, this is something that's just kind of an idea that, we're kind of pulling from the literature, saying this is what people are talking about, but we want to have some visuals here because it makes it easier to understand than, other than reading a wall of text. And so I think that's a good approach. And then, there's this last part where we have this paper on naturally supervised learning. So this is the experimental paradigm, this is the setup, and this is these are the results with an image of what you're doing in the environment. So all these things, we might add another slide on this. I don't know if Ankit has ideas about what we could add in. I've put in the main ideas here. If we have maybe another graph. What was that?
Could you give me the edit, share it and give me the edit access? So maybe I could add something.
Yeah. Yeah, I'll share the link with you. Yeah, so that's good. Yeah, so that's, I mean, that's the idea. And, you know, we want to have like, you know, you want to have like, if you 5 minutes, that's 10 slides, but generally in the title. So we could have another slide, and that would be like 2 slides per minute. So you see, the idea is you want to have a slide maybe every 30 seconds, or, you know, it depends on what you want to do. If you have a lot of images that you can go through quickly, you can have more slides, but you want to basically time these out, like say, maybe 2 slides per 30 seconds. Or if you have 3 slides, I'm going to spend 15 seconds on 2 of them and 30 seconds on one. And so, you know, you can do it that way. And that's a good way to keep within the time. And then, you know, so I think that'll work. And you know, again, like you have this example. We don't have to get too deeply into it. You just say, this is an example. Here's a graph. Here's the system on the left. Here's the graph on the right. Here's some references. Just maybe a very short description of what's going on, and then move on to the next slide. You know, that's the pace that I think you need here. So I wanted to prepare this for this week just to get, like, to show people how to do this. Again, you know, you don't have to cram a 30-minute I mean, with the Gibsonian information submission, we have the 15-minute talk, and we'll have to cram some of that into a 5-minute talk, which is actually not as hard as it seems, because you just basically have, probably in that case, you have the highlights, and, you know, just finding the right slides and getting together the slides. And we can work on that back and forth, Jesse, if you want to do that.
Yeah. Yeah, we'll have to do that. I don't have anything in for that one right now, but yes. And for the one with Avery and Jenny and company, I think we'll be meeting this weekend to talk a little bit more about that, and it's kind of a vision of yeah.
Yeah, the chat.
Yeah. What Jenny said in the chat about, you know, I think it'll be good, and sort of the overall layout for that talk will basically just be like, here's some context, here's some specific things we're doing, and here's where we want to go with it. Because it's a bit in the works, but I think it's sort of a way to put some of the concrete, make concrete some of the ideas, and be developing them more in what's ahead. So yeah, we're talking more about that a little bit after the meeting or later this weekend. So.
Yeah, that's great. I think that'd be good, especially for something that's heavily philosophical. You want to have visualizations. That's great, because it helps people connect the two things. So Jenny wanted to say something?
Not particularly. I'd be excited to continue working on this also, though, after the Neuromatch flash talk, and like turn it into a paper or something like that, because I think it really relates to the things I'm interested in.
Yeah, there's a lot of like, I don't know, I forget it. I missed your intro, so I don't know if you mentioned how like you're looking to do something in grad school for related to plot twisters and beyond. So I think this very particularly, like, one of the things that I'm understanding more as we go is there's a lot of overlap between like what Jenny has in plot twisters and what's going on, and a lot of Avery's like personal theoretical development work, and there's really interesting overlaps between them, and obviously things that I'm related to in this area too, in a mapping, and also in potential applications for things in VR, and also even some tangential things to the mentoring stuff that I was talking about. So I think there's a lot of, this is sort of a, you know, preliminary engagement on those things, but I think into the next year there'll be a lot of interesting work in that area, and so that'll be good. And there's honestly there's a few different papers that could be that this could lead into about it. So it's sort of like how do we modularize some of the things, and as Bradley kind of mentioned. So that's in the process of developing, and there'll be a lot more to say about that. So
yeah, I think that's great. Yeah, so I know there was also I think someone had mentioned in one of the Slack channels about the Gödel Escher Bach. I think it was Ankit. And he said, has anyone ever heard of this? And we just had a talk on our presentation a couple weeks ago. So I'll have to cue that up for you, Ankit. It's in one of the lab meetings, yeah. We should also revisit that, I think.
We should what?
We should revisit that. Like, right.
There's a lot of in I don't know what we want to. I don't know if we want to talk specifically about one topic right now. But like a lot that's come up adjacent to a lot of like incompleteness stuff in some things I've been looking at. That's a little bit. So yeah, I'm sure we'll come back to that.
Yeah, that's another area that's interesting. It's interesting in that people talk about it a lot. It's a
very British front window that I can see in the background.
Oh yeah,
yeah. That's the kind of row house that I grew up with. Yeah.
Yeah, and the curtains and everything. It's very
yeah.
Is in terms of like incompleteness, I think a lot of people talk about it, but there's a lot like to really understand about it, and why it's relevant. And I think there are opportunities there, I think, to say something interesting about it that people haven't mentioned before, especially with respect to like data science and some of those areas where it just I mean, even revisiting the theorem. Like last week we talked about the Conant paper from 1969, which was the cybernetic, laying out regulation. So, laying it out in terms of information theory and all this. And, having that kind of basis where you say, let's revisit this idea, but let's put some, let's kind of work through some of it and put it in a new context. I think that's a valuable thing to do. And in case of incompleteness, it could be like computation. It could be like, data science, or it could even be like neuroscience, where we're trying to derive explanations for things, and we may not necessarily have the right language currently, or we might not, we might be going down a blind alley in some area where, where we think we're doing really well. I mean, in some of the machine learning, I think, there's an assumption that we're going to move towards an optimum. We don't, there's sort of, people are invariant to some of the challenges. I don't know how well it fits into like deep learning and machine learning, but I think there's something interesting there.
Have you talked about Hector Zenel before?
Well, I may have touched on this person, but
it's not incompleteness, but certainly following Chaitin on algorithmic information theory.
Okay, yeah.
And the nice thing with at least some of Hector's work is that he gets biological. I think I mean, I haven't checked in for a while, but I think at some point he had a startup in Oxford that was focused on immunology. But I'll just drop I'm not sure where the best place to drop.
Maybe in the math channel. Yeah.
Just math? Yeah. I mean, it's really, really good, certainly really thought-provoking work in a number of domains that at least has some basis in algorithmic information theory. And and I'm just popping up on his website, and a computational natural scientist. Yeah.
Okay. Yeah.
We don't get enough of those.
Yeah. So that's like an area that it's underserved, I guess.
It's underserved.
We have talked in the past about like some of the terminology and like, so this is one of the challenges of doing like a lot of interdisciplinary work, is where you have like this new idea, And then there's this jargon, and it's like algorithmic information theory is like kind of like that, where if you dive into it, you know, you have terms, and now, you know, we've never really been able to solve that problem. It's like, you know, but it's just something that we always have to be like aware of, that, you know, when you get into a new area, if you read something that you're not familiar with, you know, one of the best ways to kind of tackle that area is to sort of get into terms and definitions. And, you know, sometimes it's like if you just make notes of terms you don't know what they mean, or things you think, oh, it's interesting, I've never thought of it that way. Sometimes people will take like a similar term and have different definitions for it, depending on the field. And they don't say that up front because they don't usually have like people coming from outside and reading their work. So it's like, you know, when we do this, and I've never really figured out how to do this. I know some groups have worked on like taxonomies or like in, you know, definition lists. But I think that in this case, you know, in some of these cases, you know, you really do have like this issue of people who use terms different ways, or they have different concepts that they, you know, think about things differently, and it's really subtle. So, you know, this is something that, again, if people have encountered in reading new work, if they're engaging in a new field, you know, please feel free to bring it up at the meetings, and we can talk about some of these things, because there's usually a history behind this. Some of us are aware of it, some of us aren't. So it's, you know, it's something that would be interesting.
Sort of along those lines, I created a new group, if anybody's interested, in computational psychiatry, and that's an area where, you know, to some degree they're building on, you know, reinforcement learning and Bayesian inference, but it's you know, I'm going through and kind of you know, just reading some papers, and, you know, trying to make sure I've got the same idea of definitions as they do, or, you know, how are they using it, how are they mapping, you know, in Niv's case, it's like, how are they mapping concepts of cognitive behavioral therapy to reinforcement learning, or to, you know, active inference. Yeah. Or, you know, different person's paper, but and wanted to also say, would there be any interest in neuromorphic computing, which, yeah, again could be its own. I've a couple of times wanted to drop in papers that relate to, you know, more kind of electrical engineering kinds of papers, but they absolutely relate, you know, especially like memristors and things like that. Like these have very clear mappings to computational neuroscience. Right. For instance, and then computational neuroscience is obviously trying to map neuroscience. Yeah.
I think we could put those in the VR neuro. We have VR neurotech, so the neurotech part would be
okay.
Yeah.
Sure. Absolutely. You know, because yeah, like you know, Human Brain Project has new work on their neuromorphic computing. You know, Brain Scales 2 is out, or, you know, is something we could talk about.
Yeah.
So spiking neural networks and the ways to do work with them at scale. You know.
Yeah. Okay, yeah. I'm interested in the applications of CBT. Where might I find that? What is CBT?
Cognitive behavioral therapy.
Oh, okay. So, yeah, you might.
Oh, okay. So you're interested. Yeah, so I am going to, yeah, just Yale Niv at Princeton was advertising a job on computational psychotherapy. And what she means by that is this mapping of CBT to RL, or, you know, and understanding not experimentally, it's understanding CBT in practice when dealing with especially PTSD, and how I mean, her examples, at least in this chapter that she shared, which I don't think is out yet, but I'll see about it. I'll definitely, if I'll post in computational psychiatry, how about put some links to the papers that are relevant, and I thought it was really interesting mapping to RL and to understanding how why it's perhaps necessary to you have this kind of Goldilocks problem of making the prediction errors just right, like not too big, not too small, and how RL has predictions about what would happen when they're too small or they're too big, right? And so, you know, really, I mean, certainly like trying to relate it to practical concerns of computational psychotherapy. And yeah, really.
Yeah, that's definitely of interest for a lot of things. So
great. And a lot of ideas off of that, or, you know, I'd be interested to follow up on a lot of different ideas on that, and just point out that the World Health Organization has a new center for collaborations on. Let me find the name. It's like the WHO Center for Collaborations on Psychological Interventions, and what they care about is rolling out CBT at scale. Is basically, you know, to rename it to rolling out CBT at scale. And the code, so Pim Kuipers, if I'm pronouncing that Dutch name correctly, is the co-director at Free University, you know, so Free University Amsterdam, and the co-director is her specialty is really dealing with refugees, and so they are, you know, again, it's like a lot of computational psychiatry work is about trying to help with the demand problem, right? Is that a lot more people need interventions that then can access them in a conventional psychiatric setting. And okay, so my daughter's coming through here, this is, you know, a big part of the WHO work. She's just getting some breakfast. Is really, I mean, this is what I love about the WHO work, is that they are preventing mental illness, right? So they are hoping that these are interventions where if left untreated, or if left, you know, without interaction, that they know that these refugee populations are at high risk for developing clinical depression and other amongst other things. And they've already shown that these interventions can prevent that, which is, you know, again, at scale, at certain percentages, right? But this is really exciting work. So I'll try and drop more links into computational psychiatry.
Okay.
Yeah, that'd be great.
And maybe mute myself.
Where's the where can I find more info about the World Health Organization?
Yeah, I'll drop it. I know I you know, don't necessarily check my Twitter feed, but it's there. I retweeted Pim on this. I don't know how far back that goes, so I'll drop links for sure. You know, join the computational psychiatry channel, and I will. And I dropped something well. Oh yeah, so computational psychiatry, the course, right, took place recently, and usually a couple weeks after it's over, they make everything freely available, right? So they charge for you to be there. If you want to catch it live and you want to interact with people, you have to pay. But then they drop everything free, and so I think that's the first link that I dropped in. and I will follow up with Yale Niv's stuff, which is she's the co-director of the Rutgers Princeton Computational Psychiatry Center, and other things for sure. PIMS, for instance. There's not a good website on it. So current, it looks like it's a new grant that they got from, it's like, from now till 2024 or something. So the website actually goes back to like the Free University's psych department page or something. But looking up the Google Scholar of, sorry, my daughter's, looking up the Google Scholar on the two co-directors was really interesting. Checking YouTube again on the kind of the two co-directors to see what presentations they've made recently. NYU Shanghai just hosted PIM for a discussion of COVID depression, I think, and kind of saying like, hey, lockdown has not helped anybody's mental health, and I didn't. Yeah. Anyway, those would be. I'm looking for presentations from the co-directors on more get a better sense of what they're thinking. So yeah, I only became aware of this a couple of weeks ago myself.
Yeah, so that's great. So yeah, if you have more, we can discuss that more in the Slack. Let me go to, I want to mention this Google Summer of Code for this coming year, because I think there's been some interest in the channels on this. So this is this is their blog post. Let me put it in the chat here. And I know some of you have been interested in this, I think. And this will actually be interesting to a lot more people, actually, if you see what they're talking about here. So Google Summer of Code has traditionally been like a very rigid program. You apply, the organization will write up an app or a project description, then people will apply to this to work on it over the summer. You pick a person, and then it has to be very focused on code or improving an existing code base or creating a coding artifact. And so, that's been the standard. This year, though, and they've changed it during COVID, there have been a lot of changes to the program. This coming year, they're going to change the program a bit more. And so you see that their focus is on open source software. So it's open source basically, but they're opening it up a little bit. So now people can propose projects that aren't really focused on university students. So you don't have to be an undergrad. You can be, any age. I don't know what their new criterion is exactly, but they realize that people could benefit from the GSoC program at various stages of their career doing various things. And so this is something, if you're, a lifelong learner, or if you have a tenuous status at a university, it doesn't matter. You can apply and get accepted into this program now. But I think what's more interesting is this sort of flexibility and size of the project. So they're trying to get people who maybe want to do bigger projects or smaller projects. They've been playing with the size of the projects in the last couple years. Now they have like two different types of projects. You can do something that's about equivalent to 175 hours of work, and larger projects that are about 350 hours of work. And so this is like two different tracks where you can propose a smaller project or a larger project depending on what you want to do. And so this is, I think, more inclusive. Then there's this increased flexibility of timing. So we have, you can spread it out over a longer period of time. Some people are doing things in the summer, then they don't want to, they either have to choose between GSoC and something else. But now they can make this more flexible. So they can expand the deadline. And I don't know where I got the idea that it's like more diverse set of projects. But I think that's something that I got an email about this, so I don't think it mentions it in this post. But I think there is this, they want to bring in people who are doing things other than just like strictly a coding project. So, you know, I think I talked to Daniela in the Slack about this, and maybe Rashab, and I don't know if Ankit was involved in that discussion, but we talked about maybe, you know, having, so I guess around January 15th is when you need to have, we work through an organization called INCF, which is the International Neuroinformatics Corps. And we send our projects to them, and then they advertise them, and then we get accepted through their organization, and they administer everything. And so we have mentors here. They would administer everything. Our students would come here, and it would be like, there would be mentoring here, there'd be project management through here, like, you know, scheduling and all that. But they would take care of all the administrative stuff. That's the way it's worked. But to do that, we need to get them project descriptions by January 15th. So that means that we need to get something in the next 2 months, roughly. If you're interested in doing a project, I'm going to try to make a file where we have them laid out. You just, you know, it's like really maybe a page at most, maybe a couple paragraphs of a description of the project. This is something I want to do. Maybe we can do co-mentorship where I'm mentoring and you're mentoring, or I don't know what the criterion they use for a mentor is. It's usually someone who's more advanced, but, you know, if we want to do a co-mentorship, we can do that as well. So if you have something that you think is a great thing we should pursue, we could put a, you know, we have to put a call for involvement out. So it's not, I can't really design a project for one person, you know, but if that's something you want to do, then you have an advantage. It's a little tricky. I don't want to be too unethical about it, but I think that, you know, that's something, Morgan was going to say something.
Well, sorry, I'm just going to go for just a little second.
Okay.
But I just wanted to say that NeurotechX does the same thing, which is they go through INCF, and we do have a couple projects. You know, so I just wanted to mention that because John Griffiths at Toronto and Sylvain Chevalier in Paris are both have projects that are very cool about collecting data, you know, if you're interested. Or in the case of Moab, which is so one of the people that Facebook Reality Labs hired up through Control Labs is Alexander Barachon, and his Moab project is an awesome benchmark of EEG data sets. So it's a really cool machine learning project that's associated with real data sets that, again, like is totally, you know, it would just kind of add to the options that people might be interested in.
Yeah. Just
want to say that. I'll be right back.
Sounds good. And yeah, I mean, I don't know how we can prevent double dipping, so we don't want to be too similar to other groups, and we don't really know what the groups are going to put out. But, you know, we want to kind of think when we get this list, we'll look around maybe at last year's projects through INCF to see if there's any overlap with groups. Because usually they'll do projects that are very similar from year to year. So, and Ankit said, yeah, but any age will be acceptable this year. No need to be enrolled. So that's definitely a plus for people.
Yeah, I'll definitely be involved with that in the sense of at least fleshing out projects, because I think that ties in with a lot of our, you know, again, apologies for being on hold about it, but like a lot of the internship stuff, I don't know if we're gonna have time to get into that this week. But like after like Neuromatch and all the other deadlines are up, like kind of revisiting all the internship and postings that we have, because, you know, that's been on the, I don't know, not main burner for a while, but it's there's a lot going on there, and so there's a lot of overlap between specific internships or postings we've had, and then now having a Google Summer of Code. But it's something, are they doing it year round, or is it specific to summer now?
Oh, I think it's summer, but you can be flexible in the deadline, so it can go into fall.
Yeah.
Yeah.
And it's like, just from like lab management perspective, like there's a lot of all of our other brain break stuff we had before, developmental AI stuff, potentially even some cognition futures related things, or I think it'd be really cool if we could have an AI ethics focused project as well.
Oh yeah.
Like even from a computational standpoint, because I haven't seen many of those. So I mean, I'd actually be really interested in trying to flesh out a project about that, and potentially some collaboration with stuff at New York Celebration of Women in Computing. So that's a really, even honestly, even just the creation of proposals for that is really interesting, and could really bring together a lot of the things that we have that are just not quite on the front burner of what we talk about here today, because there's so many things that are going on around this. So yeah.
Yeah, and yeah, speaking of the internship, we have a couple of people. We have Rebecca Lang, and then we had another person who applied to Cognition Futures, and I sent you the email, forwarded you their email materials. So if you could take a look at that, and we could, like, just on Slack, we can say whether we want to invite them or not.
I'll follow up with that later, because we're pretty much at the end of the rope today. So
yeah.
I don't know what else you wanted to try to fit in.
I'm just going to go maybe very briefly through papers, maybe 5 minutes on this.
Okay. Could I say something, like 2 things before that?
Yeah, go ahead.
Other related updates, and this is mostly just personal stuff, is like, in the interest of time, for anyone, I have the opportunity with the fellowship in the next week or so. We're having our big wrap up for the group cohort sessions, and I'm part of the. I'm in a fellowship for applying to graduate school, and it's run by some larger groups here, and the finale session is going to be very open. In terms of applying to graduate school, it's also about graduate school. So if there's any particular questions that people hear, I know Jenny's interested in some grad school stuff, and other people are as well, but like, I don't know where to best put it, but if there's any particular questions people have about graduate school and would like to have me ask them, or lead to a discussion here, or next week have a discussion about that, or so on. We kind of got a professional development channel here where kind of some of those things have been, but there's just a big opportunity for that. And I didn't have time this week, but I'm kind of compiling some things into another fellowship update, which I put into a blog post or a Medium post or something on the website that kind of will distill a lot of the discussions we've been having about research versus teaching, and tenure track and graduate school and applying, and how you're conceptualizing all the things you want to do within academia. And it's been really good. So I'll just mention that, and maybe put questions in professional development if you have any, and we'll have a little bit of resources there adjacent to that too. On a slightly related note, and again, we don't have time for it, the mentorship project that I've been talking about is still in the works and going to happen. It will probably launch more at the end of December, January. But a lot of things, even I've actually been looking at like E.O. Wilson's work, unrelated to the fact that he wrote the Letters to Young Scientist stuff. A lot of his principles and ideas and concepts there are really good and hold pretty well to a lot of things. So I actually kind of unintentionally came across those again this week in his sort of outreach and encouraging people to develop in certain ways. So that's cool. But the mentorship project is happening. The fellowship is happening. There's one other thing. What was it? I don't quite remember, but yeah, that's it. We can go to the papers and we'll follow up more on Slack. Okay. Definitely follow up about the email and interest for the internships and things like that. So yeah.
Okay, that sounds good. Thank you for that.
And also, like, I don't know if Jenny wanted to say anything, because I know we're kind of at the end of the line here. So thank you for coming and staying the whole time here, Jenny. But if you had any like questions or things you wanted to say, just like, I don't know if you have to go soon or if you're pressed for time. So.
I'm excited to be here, and yeah, this was a really interesting first session. I didn't follow every little thing, but I have been exploring the Slack and opening papers that seem interesting. Yeah, I'd be super interested in the professional development stuff. I'm currently thinking about a grad program, so yeah, just preparing research proposal and doing some writing on things like that. So yeah.
Okay. All right. More there, more later, obviously. So thanks.
Yeah, thank you. Yeah, that's great. So we'll finish up with papers, and I don't know if I want to get too much into any one paper here. I did find that I have a copy of this book, E.O. Wilson's Genesis, the digital copy. This is The Deep Origin of Societies. This is a book that he put out. I don't remember how far back this was published. Oh, this is a fairly recent book.
Yeah, that's fairly recent.
Yeah, so I have have access to this digitally. I also have this paper on course control on Drosophila. So there's this walking strides, direct, rapid, and flexible recruitment of visual circuits for course control. So this is a paper on sort of like visual motor control in Drosophila. So the abstract reads, flexible mapping between activity and sensory systems and movement parameters is a hallmark of successful motor control. So this involves a lot of feedbacks between moving around the environment, visual system, and motor system, and probably also representations of space, things like that. This flexibility depends on continuous comparison of short-term postural dynamics and longer-term goals of an animal, thereby necessitating neural mechanisms that operate across multiple timescales. So in this paper, they did some work on Drosophila, which is something you can easily study in terms of its movement in an arena. They build arenas for Drosophila. They have different stimuli in the arena. They can orient things in different ways, and then they can record from the brain. And so they demonstrate that the activity of leg mechanosensory cells propagating via specific ascending neurons, which signal up to the brain, is critical to provide a clock signal to the visual circuit for stride-by-stride steering adjustments, and at longer time scales, information on speed-associated motor context. So it's giving all this information about speed and timing and everything. And so this is the way, they study this in humans as well. And it's interesting that in Drosophila, which is a much different neural system, it has a much different visual system and a much different, the motor system is somewhat similar in terms of using motor neurons and interneurons, but it's a very different system. And so it's interesting you can extract sort of these feedback loops in both systems in different ways. And it's an interesting set of systems, because it really is something that you can establish this sort of feedback and really get a handle on. So there are a lot of interesting figures in this paper about their experimental setup and the recordings that they're doing, and the walking versus stationary activity in the fly. And so you get all this information. So this is a very good paper.
Where did you post that?
Oh, this is in our so I can post this with the recording of the talk in the general channel.
Great.
But this is in the papers folder.
So Logan Collins has a Facebook group called Neural Circuits, and a lot of paper, that looks like a perfect neural circuits paper.
Logan Thrasher?
Yeah.
Oh, okay.
I'm decent friends with him. So
Cool. Yeah. So he did an early presentation at Neurotech X, and which blew me away. And yeah, so I just posted a thing about that Johns Hopkins released on a paper of theirs, but spiderweb weaving.
Oh, okay.
And again, seems, is perfect for for teasing apart neural circuits.
Oh, okay, yeah, that would be great.
But that looks really interesting. Yeah.
All right. And then the next paper I want to go over. Let's see. This is not the right one. There we go. This one here. This is levels of biological plausibility. So this is kind of a shift, but this is towards sort of this idea of biological plausibility and mechanism as is more philosophical, but yet it has a lot to do with sort of what we talk about when we talk about the brain and some of these mechanisms. So this is Bradly Love from University College London. The abstract reads, notions of mechanism, emergence, reduction, and explanation, which we talk about a lot. We talk about emergence a lot. We talk about reductionism. We talk about mechanism. Those are all tied to levels of analysis. And so there's a literature on different levels of analysis, but this is a sort of a review, again, of these concepts. I cover the relationship between lower and higher levels. So this is maybe physiology versus behavior, or genes versus the brain. So you have to define those levels. But you have those lower and higher levels, and they interact, or there's some signal from lower to higher level. And then suggesting a level of mechanism approach for neuroscience, which the components of a mechanism can themselves be further decomposed. So in other words, you have these different levels, and you try to find a mechanism. So you say the genes influence maybe a neuron, and then those neurons influence behavior, and then behavior influences maybe social interactions, and there might be a feedback there. So that's what they mean by these levels, and then decomposing those is to find maybe finer grain levels within those levels. So this is kind of what they're trying to do. And there's also an argument that the scientist's goals are best realized by focusing on pragmatic concerns rather than on metaphysical claims about what is real. So in other words, if there's this huge debate about representation, are representations real? Well, maybe we don't care so much about that. Maybe we care about a specific system, like the motor system, and what is it doing, and what is it, maybe there's a motor representation that is maybe independent of the argument about representations and how they're, if they're on manifolds or whatever. So there's that aspect of it as well. Inexplicably, neuroscientists are enchanted by both reduction and emergence. So, people who think about emergence, they think about things emerging from its component parts and having properties that are greater than its component parts, whereas reductionists are interested in those component parts and how they interact. And so there's this sort of split. There's a split. People like emergence, but they also like reduction. So how do you bring those together? A fascination with reduction is misplaced, given that the theory is neither sufficiently developed nor formal to allow it. So in other words, we don't really have a good way of, we look for mechanisms through reductionist means, we look for a specific set of relationships. But sometimes those aren't really, theoretically, they don't necessarily make sense. Or, just in terms of the broader context. Whereas metaphysical claims of emergence bring physicalism into question. So, emergence then, sometimes it escapes the bounds of what we can observe. And so maybe, we need to be a little bit more careful when we use the term emergence. Moreover, neuroscience existence as a discipline is owned to higher level concepts that prove useful in practice. So neuroscience will deal with the mind, where it will deal with some representation that are higher than the component parts in terms of the idea, and it's useful. So maybe those are the component that maybe that's a type of emergence we need to focus on. So this kind of goes through a bit of this a little bit more. Model selection can help reduce theoretical confusions and direct empirical investigations. So there are different methods for model selection. You have one being able to choose between models using different types of criterion. People use there's a information theoretic approach to this. There are other approaches where you select the model that performs the best given your data. And so this can help direct empirical investigations instead of just kind of saying, I like this model because it fits my theory. Although measures themselves, such as behavior, bold signal, and single unit recordings, are not levels of analysis per se, Like levels, no measure is fundamental, and understanding how measures relate can hasten scientific progress. So we usually pick measures of the brain, proxies of the brain, but those actually exist at different levels, like single unit recordings or single neurons. Behavior is, the organism, and bold is sort of like, collective behavior of neurons. But those aren't really levels in and of themselves. They're just proxies or measures for levels. And so we need to understand the difference. And so this article kind of goes through a lot of this stuff. It's sort of an introduction, I think, to a special issue. So there's a lot of interesting stuff about what is gained and lost traversing levels. Some of these other more epistemological issues of different levels of analysis, reduction and emergence. I think it's a really interesting approach because, we talk about these things, we don't really kind of think about them very deeply when we
Sorry, I saw ACTAR pass there too.
Oh yeah, cognitive model of ACTAR, which is of course another way to sort of, it's one of those representations that are useful. They don't necessarily exist as like a biological level, but they're things that we can use in the real world that come from like what the brain is doing. So these models were characterized originally as being implausible. They're early connectionist models, but those just because they don't connect with brain data doesn't mean that they don't behave kind of like what the brain does. And so that's kind of the idea here, is that we have a lot of things in neuroscience that don't fit together very well, according to the, either the levels view or, just throwing out the levels view. We have to kind of reconcile these things. So yes, well, let's finish for today. Thank you for attending, and I'll put those last papers in the chat or in the general channel.
And the Botvinnik paper too. Sorry.
Yeah.
The Irina Higgins, or I'll look that up too.
Yeah, I'll put that in there.
And I just dropped a link in general. It's Aaron Schwartz Day is coming up.
Yes.
And so anyway, check it out and see if there's anything. If nothing else, you can catch some talks.
Yeah. Okay.
Yeah, that'll be. Maybe we can talk about that for like ethics next time. But yeah, thanks everybody for being here, and take care.
All right, take care. Have a good week. Thank you.
Thank you for having me.